In this lesson, we're going to take a look at more solving quadratics when we're opening up with a fraction. Now, as I stated in the last problem with the quadratic formula, we want to do what I call fraction busting. And what that is you want to figure out what your common denominator is. And sometimes they're not written as a fraction, so like the x should really be over the 1, the 5 should be over 1. The least common denominator then is going to be x. So I want these, if I was trying to add these as fractions, I would want them to all have x's. Well, I don't really want to add them. I want to bust the fractions up because I've never liked them, so we want to fight back, right? So we want to kind of kill the fractions here a little bit and bust them up. So what I do is I multiply each thing by that common denominator, which is x, or x over 1. And so I times each individual thing, everything, by an x. What happens is I end up with this canceling, the x's are gone, and that gives me just 14 equals, these multiply to be x squared, and then I get negative 5x. So my problem that looked really complicated at the beginning is now much better. So I can rewrite it. I want to move the 14 over, subtract it, and I can rewrite it to be x squared minus 5x minus 14 equals 0. Okay? So now I want to go through my process and decide if I can actually factor it or if I have to use quadratic formula. The best method is to just go ahead and try to do a magic x on the problem and put the negative 14 times the 1 on top, so negative 14, and then 5. Negative 5. So the question is can you figure out anything that multiplies to be negative 14 that adds to be negative 5? And I'm thinking of negative 7, positive 2. Because negative 7, positive 2 work, I can continue to use my magic x, which means that I divide both of these by x and whatever number's in front. But here it's just an x. So divide by x. And so I can rewrite this to be x minus 7 times x plus 2 equals 0. Okay? So I factored it rather than use quadratic formula because this is much better if I don't have to use quadratic formula. So I have x minus 7 equals 0, which means that x equals 7. And then I get x plus 2 equals 0, which means that x equals negative 2. These are your two answers. So now we'll take a look at another one, and of course we're just going to get more complicated as we go through. And it's just more complicated to find the common denominator. This time we have three fractions, 1 over 1, negative 3 over x, and negative 28 over x squared. The common denominator is x squared because I can make this x turn into an x squared by timesing it by an x. I can make the 1 turn into an x squared by timesing it by an x squared. So again, I still don't want common denominators. I want to bust the fractions up. So I do that by timesing everything by the x squared. Technically I'm timesing the 0 by the x squared as well. So what happens is now my x squareds cancel, and I'm left with negative 28. My 1x actually does reduce one of the x's up here, so that gives me negative 3x, and then my x squared out in front is left. Equals 0 times x squared is just 0. So now I'm left with a nice quadratic. It all clears out. There's no weird fractions anymore. And so now I just have to decide how to solve it. Again, my preferred method is to see if I have a magic x. So I multiply and so then can factor. And so I get negative 28 times the 1 in front. So 1 times 28, negative 28 gives me negative 28 on top. On the bottom I get negative 3. So then I try to factor anything that multiplies to be 28 and adds to be 3. And hopefully you're thinking about 7 and 4. If I make the 7 negative, that'll subtract to be negative 3 and multiply to be negative 28. So now that I figured that out, I need to times by the x and whatever numbers, divide by the x and whatever numbers in front of it, getting rid of the square. So I just divide by an x, and then that turns out to be x minus 7 times x plus 4 equals 0. Which means my two answers will be x equals positive 7 and x equals negative 4. And that's because you can set each one equal to 0, x minus 7 equals 0, and x plus 4 equals 0, and then you just, of course, subtract the 4 and add the 7 to get these two answers. So now we're going to take a look at an even more complicated one. And you can see here I've got three fractions. I got 1 over 1, I've got negative 1 over 2x plus 1, and then I've got negative 1 over 2x plus 1 squared. Well, I can make this 2x plus 1 turn into this one by timesing it by 2x plus 1 squared. I could make the 1 turn into a 2x plus 1 squared, which means the 2x plus 1 squared is my least common denominator. So that's what I want to multiply everything by to get my fractions to bust. So times this one by 2x plus 1 squared, and finally times the 1 by 2x plus 1 squared. Again, it looks really complicated, and it starts off that way, but it'll work out really nice. So now what happens is my fractions go ahead and bust. So these are gone, and then one of the 2x plus 1's here cancels out with the 1 on top, and then this one multiplies. So I'm left with 2x plus 1 squared minus a 2x plus 1. And now we got to make sure that we have our parentheses around this one because there is a negative sign. And if we lose our negative sign, it actually makes the problem wrong. And finally, we have a negative 1. Now this negative, again, in the middle, came from this sign here. So again, don't lose the negative sign because it is important to distribute that. Okay. So now, we actually should distribute that negative sign and give ourselves negative 2x minus 1 minus 1. But this part out in front needs to be worked out also. Now the easy way of doing that is, I think I've showed in a previous lesson, if you're squaring this, do not, first of all, distribute the 2. You can't do that. Rather, what you need to do, or need to think through, is it's 2x plus 1 times 2x plus 1. Okay? So you can FOIL that, or my easy method is you just take this number, square it. So that gives you 4x squared. Then you take the 2x and you times it by the 1 and double it. 2x times 1 is just going to be 2x doubled is going to be positive 4x. And finally you take this number, the 1, and square it, which is just plus 1. Otherwise, just FOIL that and you'll come up with the same answer I just got. Okay? So now we take this and have to combine all our like terms, remembering that this is equal to 0 still. Okay? So if I rewrite it, it's going to be 4x squared plus 4x minus 2x, which is going to give me 2x. And then I need my 1, negative 1, so 1, negative 1, negative 1. So these will cancel and I'm just left with minus 1 equals 0. So now I have to factor and solve. So all that work so far to get ready to factor and solve. So I'm going to go ahead and erase so that I can do that. So if I try my magic x, I should multiply my 4 times my negative 1 to get negative 4 on top. The 2 goes on bottom. So now you're trying to figure out any factors of 4 that will add to be 2. Well, you can work really hard at doing that, but I don't think anything's going to come to mind. So that means we can't solve this by factoring. We actually have to solve it using the quadratic formula. And that means I'm going to take negative 2, so negative b, plus or minus the square root, b squared, which would be 4, minus 4 times my a is 4 times negative 1. Okay. So now that's all over 2 times 4. So I need to reduce this, and this would give me 4 minus 4 times negative 1, so this is going to be positive 16. So that's 4 plus 16, which means that this is 20. So really this is negative 2 plus or minus the square root of 20 all over 8. Okay, and then we want to reduce if possible, because I can do a hockey stick with 20. So I get 20, hockey stick, 2, 10, 2, and 5. So that means I can pull out a 2. In other words, this will rewrite to be 2, negative 2, sorry, plus or minus this 2 square root of 5, all over 8. Okay? And then you should finish with a little salsa verde Dorito problem. Divide everything by 2, which means that I'll end up with negative 1 plus or minus 1 root 5 over 8. So yes, this was a difficult problem. You might have to watch certain steps twice, or hopefully you get the point enough that you can attack one of the problems on the lab.